Hello everyone, good evening, and thanks for joining today. For those of you who are joining the Hash Include session for the first time and wondering what it is, it's a forum run by Gojek for discussions around tech. We host people such as Piyush and learn from them about the technologies they're working on, and it's a community to discuss interesting tech. I'll just give a quick intro about Piyush as well before handing it over to him. Piyush is the co-founder and CTO of Last9. He was previously head of SRE and DevOps at Trusting Social. A fact that I just learned right now is that Piyush has worked for Gojek as well and was one of the early members who built Go Live. Uh, he was also the architect of DataStax's managed cloud offering for hosting Cassandra, which is used by several Fortune 500 companies. He has helped build several important consumer products across Southeast Asia. Uh, yeah, over to you, Piyush. Please fill in the details which I left. And thank you so much for taking out the time for doing this with us today.
Thanks, Ayush. I didn't know that much about me, as much as you mentioned. Uh, yeah, so I guess I can just skim through the introduction slide. We are Last9.io, a site reliability platform. And yeah, I work there as a CTO and a software engineer, a bug fixer also, by the day. So this session, I want to talk primarily about SLOs, service level objectives, and how they can be misleading. What is in it for you? How the world views these SLOs. Over the industry, I've actually seen that many a times we have been too liberal in using these numbers and going about chasing them without putting too much thought or measurement around how do we measure them, what do we leave out, how and the clinical nature of these numbers, how easy it is to actually botch these numbers, and what do we do about it. So before we start anything, like SLO simply means for if this is the first time you're hearing this term, is a service level objective. Every objective in this world requires an indicator to understand whether we are getting there or not. Now, an indicator is of a level. If I have to say that you have to become better or good, there has to be a measurement around it. One is on what ground and level should I become better? Should I become a better orator? Should I become better in my diction? Should I become better in my programming? What should I become better at? And there has to be a way to measure it. These are called the service levels, is how I define it. Among these levels, the most popular ones are availability. When you build a service could be anything that you mention as your digital property. It could either be an API, it could be a website, it could be a mobile app which is being used, a mobile app which you distribute. It could be anything which you actually run your digital business about, and the availability of it. A lack of availability looks something like this. Speed is another level that is measured. What does the speed look like? We very well know the spinner. A lack of speed looks like this. Then there's another measurement of it called correctness. Correctness of a particular service. This doesn't hit as obviously, but correctness is if I am trying to receive data from your service, let's say if I uploaded a photo, but when I refresh, I don't see the photo. This is not really correct behavior. Or if I like something, but a few minutes later, the like is gone or is not there. Now, this is the correctness aspect of it. A derivative of correctness is also freshness, which is the data is there, it just hasn't reached me yet. Now, these are multiple types of objectives that need to be measured, and these are service levels. Now, the bigger question here is all of these are attributes. How do we go about measuring them? Because if there's a level that needs to be measured, if I go back to all of these levels, how do I measure availability? Well, one of the simplest measurements here is we count the number of hours about it. If a service, if I'm a druggist, I'm a chemical store, I'm supposed to be open 24 hours. Now there is a finite number here. 24 hours is what I have to be open, and I can actually calculate availability of it. How about speed? Is speed something, should we calculate it as Mbps or should we calculate it as milliseconds? Now, this is where ambiguity starts kicking in. Here, what's happening here, if you already realize that the measurement angles of these levels are becoming more and more complex. Speed could be measured as either of the two. There is no one right way of measuring all of this. As we get deeper, how do you measure correctness ever? How do I say something is more correct or less correct? Well, in terms of our services, we still have a way to go about this. What we do is we measure HTTP status codes. What we would say is that, look, X status code or a HTTP 500 is an error condition. But anything which is 400 is probably not an error condition because it's a valid response. So you could now, but this could actually be unique to every service as well. There is no pre-computed or a proven formula which says that, look, 200 status code plus 300 status code, but omit 422 or 412 and everything else. This is unique to how you have written your HTTP or your REST schemas as well. One of the toughest ones though is measuring freshness. How do you measure freshness? If I was to ask you how fresh is a bottle of wine or an apple or a fruit, there's no qualitative measurement that we have here. And as these attributes, as these levels become more and more abstract, the measurement of it also becomes pretty complicated. However, I will actually come back, all of this I'll bring it down to just one single, availability. We're going to just start with that and stick with that. While it may have been looked the easiest to us because availability is measured in hours, I will only just try to go into the layers of it, of how that simplest unit can actually confuse us as well and probably go wrong. Now that we have gotten these levels and these measurements, comes the notion of service level objectives. A service level objective, this is something that I borrow from New Relic, and these guys actually say it in a very good way. In a given week, day, or a month, X should be less than or greater than or else. It's a very simple way of putting it, that in a given week or day or month, my latency should be less than 500 milliseconds, else we need to spawn another server. That's a violation and an agreement that we need to actually do something about it. Very simplistically put, this actually captures both what SLI and SLOs are. Coming back to the notion of uptime, this is the simplest, most measure that we have taken of availability of servers. And while we are measuring that, I have a question here. I want to throw something and say, if I am looking at something like this and it says 99.92% uptime, I'm sure most of you relate with this. This is an email alert that you get from Pingdom. Is this really 3 nines that we are achieving here? Is a bigger question. And if it is, how do we go about it? One of the biggest questions here is, sure, it's a 99.92% uptime, but over what? Is it 99.92% up during a day, a week, a month, or a year? And these nines need to be fabricated and calculated accordingly. If I just look at a simple tabular version of it, don't quote me if I've gotten something wrong here. This is just, I think I've gotten them right, but in case I haven't, you can just find them anywhere on Google. If I was to say I'm 99% up, but I measure this per year, a simplest 99% could actually mean 3.7 days of downtime. If I say I measure it how does this axis actually vary and how are they important? That's really good here. When I say I will measure 99% over a year, I could potentially be down for 3.7 days and yet be under my service level objective. But is this the right behavior? Because let's say out of 365 days, I'm a shopping cart. I'm up through the days, but from Christmas till 29, I'm actually down. So the most 4 important days of the year, the site was down. Technically, I've beaten 99%, or maybe I'm actually better than it as well. But to business, it's of no use. So is this a ration that I keep accumulating? or do I need to come up with a smaller unit of it? Which is why there are other variations available as well. You could go per month, and the same value would mean that, look, you could be down for 7.3 hours. And if too bad, if you weren't down in that month, it's okay. You don't carry that forward. It's not like the data plan that we have on our mobile phones, you know, that if you don't use your entire GBs, it will be carried forward to the next month. It doesn't work that way. You have to consume it. Now, the downside and the implication of these numbers, these are very important. The more you go towards a year, though it gives you it gives you more flexibility, but what it also does is a single duration of an outage could actually become very large as well, which may be pretty much counter of what you wanted to do as a business to begin with. The downside of keeping it too small, let's take 99.9%. 8.7 hours of downtime in a year still is okay. You know, like you would say that, look, that's look doable. But if I shrink it down to just everyday rolling window, you only have 1.4 minutes of a downtime. What that means is that if every day, if I was down as a service and I don't come back up in 1.4 minutes, this is lost. The same thing applies for 99. And as you see, as each 9 keeps increasing, the impact or the amount of reaction time that we are going to be left with is almost negligible. Think about it. 99.99 is 8.6 seconds a day. For sure, it takes more than that for me to open my email, let alone a fact that I'll see my email, I would actually react to it and then bring that site up. The clear implication here happening is that SLOs give you not a reaction time. They are, I'll cover this thoroughly, but I just wanted to highlight this out here. A service level objective, as it goes deeper down the nines, the objective there is a proof of how good you have been, of all your monitoring, all your technologies that have been installed, all automation. Think about it. By 99.99, there's no way a manual human could actually be doing all of this. In 8.6 seconds, get an alert, react to it, diagnose the problem, find the problem, fix the problem, and bring the site back. Not happening. To be honest, it's not even happening at 99. It was happening way earlier. So this journey of nines is actually a journey of your culture. It's not just a random number that we aspire for. And obviously, there's cost to it as well. Now, moving forward. So we just clearly identified that every SLO needs to be seen within a window that expires. It's a moving window. I'll only calculate this on a week or a month or a day or a year. My personal favorite has been a week, because what a week does is it gives an aggressive enough timeline where a manual effort can no longer be warranted, because in a month, I will say 43 minutes of downtime, I may become complacent. You know, as a guy who's actually running reliability, I may get complacent about it. But I know that, oh, this is only 10 minutes in a week. There's no way I can actually do this manually. I need to have my run books in place. I need to have all my automations in place. Only then I'm going to hit it. So week seems to be, to me as an opinion, not a fact, a fair trade-off that I've actually kept. How do we measure uptime? It's a simple maths. There's a total time, you subtract from it, down from it. There are two words here, total time. It's a constant in this world. So that's at least something that we don't have to worry about, right? There's only certain number of hours in a day, in a month, in a year. So that's not a dynamic variable. What's dynamic is downtime. So if we have 100, we just subtract from it how long have we been down, and that's a simple measurement. It takes us to how do we measure downtime? Now this is where, as you know, like when we ask ourselves, how do we measure downtime? The first thing that we ask, I mean, I would have loved to conduct a poll right now, but that's okay. Way of measuring downtime, suddenly in our imagination, we are thinking of Neural X, we are thinking of Prometheus, we are thinking of Datadog. You know, we are thinking all these tools that we have been habitual with, we have been acquainted with, we've heard of. I want to ask a very simple question. If I gave you no measure of external observation, can you tell me how long were you asleep? The point we're trying to make here is, from inside of a system, you can never measure a downtime. If you are sleeping and I take away every single clock away from you, and I take away every single person away from you who can actually keep that measurement, it's effectively what we're saying is that an external clock, there is no way you can tell me how long you were asleep. You can only give me an approximate guess, but you would never know. So clearly, what are we suggesting? What we're suggesting is we need an external observation to actually detect what is down and what is not. There are multiple ways to go about this. I'll start with the most complicated one, which actually is the easiest one. A lot of time we say that let's install these device SDKs. The job of a device SDK is to emit metric. They keep emitting metrics, and a metric tells whether X device was, and this is where the plethora of tools of available from Segment.io, etc., and everything around that. Like let's not call out the name, but every single service out there as a device SDK on your application on your front end will actually come handy. But is that something which can give me a downtime measurement? Now let's look at some maths here, right? Let's say we are aiming for 99.9 in a week. That's almost like 10 minutes of downtime. That's 1.4 minutes a day. I am a service where my digital property is worth something. Now, obviously, I mean, we would like to assume that there's a significant amount of load happening here where a downtime matters to us. In a connected world, there could be so many devices. A very fair, simple assumption, 10,000 devices. Let's take a sample that 500 milliseconds it will take for each heartbeat to reach me. I have only 1.4 minutes to report and fix the problem. In this all of 1.4 minutes, the entire data across those 10,000 devices has to be aggregated. See which one did not make through to that service. So there is a data processing pipeline which will be in the picture as well. There is a to and fro, there's speed of light as well. There are ISPs as well involved. There's everything involved, only 1.4 minutes. This is something which the amount of compute that you'll have to spend is massive. Like even if I say that you were actually able to run a pipeline which will find this data in 30 seconds, you're only and only left with 70 seconds now to fix the problem. Now, which also includes you getting alerted. So the alerts will also have their own cycle. The maths here is simple. It's not possible. This can be done. Now let's take another example here, another challenge of this approach. Let's say 1% of these devices were experiencing an ISP fault. Now they can't reach your service. For sure, they cannot send out the metrics as well. So your 99.9% is only 99% accurate. There's 1% of your devices which are still not there. Now, what does this give? Does it tell me that I am 99.99 up still? Or would you say that no, it's 99% of 99.9? How do you measure what you don't know? This takes me back to a very, very famous quote. I just really love it. 60% of the time, it works every time. This is from a movie Anchorman. And very next dialogue to it is they've done research. So anyway, the next challenge that we need to talk here about discussing SLOs is SLOs are layered. What I mean by layer is we're still sticking to, let's say we're going to find uptime of our service. The reason is that, hey, I'm hosting a digital property, I need to measure an uptime of it. What does a typical connection flow look like? Client will call a firewall. Firewall will call a load balancer. Load balancer calls a proxy. Proxy calls a handler. Now, handler is the one where my code is, something which I'm only in control of. Everything else, firewall, I got it from AWS or GCP, load balancer, something similar. Proxy, I'll be using something like Ambassador, I'll be using something like something. Typically not even my code, which I'm actually measuring my uptime for. The further in my application, the real one here, the one which could actually go down is so far away from this entire chain of the client calling it. What would happen? If my handler is down, a proxy is going to raise a 500, is not going to return a downtime error, is going to raise an error. If proxy goes down, load balancer would also throw an error of it not being present. It's a 500. So what we are measuring as an uptime is actually going to show up as an error ratio or a correctness SLO into some other layer. A SLO is never a pure SLO that you say, hey, this is an uptime. A SLO is an aggregation of all the layers underneath. And it's very well possible that what a business calls as uptime, what you're actually measuring is an error ratio. And it's not really an uptime, because how often would AWS's infrastructure would have had that problem? And even if it did, there's literally nothing you could have done about it. So all those 1.4 minutes, you can just sit there, watch Twitter and hope that the problem gets resolved and nothing else. So technically, it's important that every time when we hear from this business that, look, we have to achieve an uptime, we need to go back and ask ourselves and also the business team and everybody involved, whoever is a stakeholder, what SLO are we really capturing here? Are we really capturing the uptime, or are we really capturing the error ratio? And these numbers don't matter because they need to attach to a business goal, and then the derivative of it could look anything. Now that we know the challenges, we need to have a solution. So clearly this approach of device SDK is going to be marked. Like we can't go out with this. So here comes the concept of downtime monitors. They're not really uptime monitor, because nobody's interested in knowing how long are you up. And I'll tell you why. It is actually more interested in the downtime of it, because I'm going to throw that same formula that we discussed a while back. Uptime is basically just, now we have to compute a percentage, time up divided by time up plus time down, percentage, and that's as simple as that. A very, very interesting thing, and this is where you would throw in all those pingdom alerts, like almost every company these days has a uptime alert, like even Freshdesk has it. All of these, any of these, like GCP will give you one, AWS will give you one, CloudWatch will give you one. The interesting thing across all of these is the downtime is of how the monitor is going to see it, not how the customer is going to see it. All your 1% customers who could not reach you are still not going to reach you. So this uptime is worth whatever it is worth to the monitor, not to anybody else. This is a very important understanding that we need to have here. This actually goes back into also another, this is a paper I was reading, and for Google Spanner, like they said that, look, we are a highly available and a consistent and a partition tolerant database. And the word spread around like, oh, so you have beaten CAP theorem. And their answer is right on the blog, and they mentioned it. No, we haven't beaten CAP theorem. It's just that we are more available than your monitoring system is. Simple as that. So next is, if we are facing such a tough time, having this 100% uptime, how are these downtime monitors managing 100% uptime? Clearly, they're not holier than thou. They're going to have this problem as well. If I have a problem keeping my service 100%, and it's not easy, for sure they're going to have a problem as well. So it's never 100%. What you are measuring, even from a downtime monitor, is actually not 100%. Let's walk through these challenges as well. Any uptime monitor will actually give you a reliability percentage as well. They're not going to give you 100%. They would say that, okay, I offer a 99.99% per month. So if we go back and do the maths here, this 99.9 and your 99.9, there's no guarantee they're going to overlap with each other. And for the 4 minutes that the downtime monitor was down, was it overlapping with your 4 minutes, or was it more than those 4 minutes? Because while the downtime monitor was down, you don't know whether you were up or not. So it could be actually 4 plus 4. So your 4 minutes of 99.9 has already been sacrificed, because, well, there wasn't a downtime monitor that could actually give you 100%. So what's the answer? Well, we go with the next solution. We say that, okay, let's pick up Geo-Balanced monitors. We'll have multiple monitors who are hitting our services. If you haven't realized by now, we are already convoluting this battle. I just had a simple ask. How do I monitor my uptime? And now I'm actually dealing with geographical monitors, which are on different ISP lines, which are different service providers altogether. Well, one of the solutions is ignorance, obviously, that I don't care about any of this, but then it's not really clinical. Like I shouldn't be chasing a clinical number if my approach isn't clinical about it. The biggest challenge with geo-balanced monitors is, should this failure of one geography be called a downtime, or should it be actually ruled out? Let's hear this out, right? Let's say my service is actually deployed in Mumbai, and I got monitors, and obviously there are services which are being accessing it from Singapore as well. A large traffic is from Mumbai as well, and some Southeast Asia as well. If Singapore detects my service to be down, is this actually down or is it not down? Should I call? But Mumbai can reach it. How should I see this? This is a constant challenge. There's no real answer for it. Like, there's nothing we can do about this. One of the third things that most of these monitors do is called state-based monitoring. Now, this is the third challenge, and the foremost challenge is no monitor is going to hit you every single second. There is a frequency to it. And this frequency is very important to calibrate. I can't obviously make a call every single second because my entire load will just be the request there. And do remember, it has to be a deep enough call of health check, which goes and punches a hole through my entire load balancer, proxy, firewall, the whole chain that we talked about before it actually hits the right service where it is meaningful, because the customer is not going to return from the load balancer. They would actually go some sort of compute logic all the way down to your server. So the health check also has to mimic and emulate something very similar, because only then it's sensible. Otherwise it will just be, yeah, load balancer is up. So technically you're going to pump a lot of money to just prove that AWS's load balancer is up, but not your own service. If it has to be your own service, it has to be deep. If it has to be deep, then technically if you make a call every single second, your entire load could just be your health monitor itself. I've seen that. I've done that mistake many a times where we did analysis and we realized that 80% of the traffic was our health traffic itself. And just by killing that, we could actually save 40% of the cost. So state-based, yeah. So because it cannot hit every single millisecond, there are only going to be states in there. So we need to introduce a notion of state, because it comes back every now and then, periodically. We need to define states. So 3 states are okay, unknown, and down. Remember we said that downtime monitors are also going to run into challenges. They are also going to run into network issues. They are also going to run into partitions. They are exactly the same code as we are. They write the same languages we write. They write the same Go clients that we do, or Erlang clients that we do. So they're going to have exact same challenge. So they will retry as well, because that's what we do when a network failure happens. We retry an operation. So while the downtime monitor is retrying, the state is unknown. So these are 3 states. Sadly, there are no polls. I would have asked you to actually measure the uptime of a given situation. Let's say there are 3, let's say we are very aggressive, very, very aggressive in measuring our check, and we send a request every 10 seconds. 10 second number 1, the status is okay. At 10, the status is also okay. At 11, the status comes as unknown. 10 seconds later, the state is okay. Simplest question, does this mean 100% uptime, or does it not mean 100% uptime? Was I down during those 10 seconds, 11 seconds, or was I up during those 11 seconds? And these 11 seconds are important, because go back to a graph. Each one of these 11 seconds multiplied by just 10 times become 1.4 minutes. Now, exactly, yeah, almost precisely that. Yeah, so let's take another timeline. Okay, unknown, 10 seconds later down, and 21 it's okay again. What is the timeline for this? There is no answer to this. There is no mathematical answer to this. There is no one way to do this. It's on you, on how do you deploy this maths. One could say is, look, unknown, and this is where rules become absolutely massively complicated. Starting from, if there's a transition from okay to unknown and to okay, this will be counted as uptime. If there's a transition from okay to unknown to down, then it is counted as a downtime. Now, but this is up to your interpretation, and every single downtime monitor out there is actually doing these approximations. because this is the exact same metric data point that sit in the database, but you need to do something about it. So it's all aggregated. Now, lastly, while this is the same problem that we're discussing, that during a monitor's sleep period, the 10 seconds that it did not make a call to you, your system could actually would have been down or maybe not down. While we're saying all of this, so technically what I'm trying to suggest and say here and conclude a point is that the simplest thing that we take for granted as uptime, and we're very, very at times careless about it, to say that, look, 99% uptime, there's a lot that goes underneath in there. And it's almost possible that we are even not measuring it correctly. So what's the conclusion of all of this? Well, the first biggest conclusion that I want you to take here is there is no one true single service level objective. An uptime of one layer could actually be measured as an error of another. Uptime is mostly and massively aggregated. Does that mean that you should not use an uptime? No. What this means is that by the time we're actually dealing in these currencies of nines, having a manual intervention is almost impossible. You're not going to land into this situation of being 99.9% uptime. Let me conclude this with line first, that as the nines increase, service level objectives become a confirmation of proactivity than a measure of reactivity. I want to peel this phrase a little here. What I'm trying to suggest is, as these nines increase and as you go closer towards seconds and minutes of resolution, it is almost impossible to assume that you as a culture will shift right towards it. It's a baseline that you're increasing gradually. So you were at 90% at one point of time. You had certain automation. From there, you landed at 95. From there, you landed at 99. Almost to a degree that a system which is 99% uptime is as good as a 100% uptime system. There are only very few marginal things which are very expensive, have not been installed and have not been adopted yet. But the journey to even get there involves one, not humans, but actually machines and systems reporting, calculating, and taking actions out of all of this. So rather than we chase a straight uptime number or an objective, we need to chase that passage. That passage will actually bring us to all these nines that we want to achieve. That's pretty much the end of my talk here. Yeah.
Okay. I think you've left a lot of us scratching our heads, Piyush, on how exactly does this work. So we have a couple of questions. Vamsi is asking, what is the unknown which you showed? Is it the request is still processing or the status unknown? What is it?
Yeah, so
Do you know?
status unknown is a state where a network monitor cannot decide whether it is down, because whether basically it cannot. So there's a timeout. Obviously, a network monitor which is actually trying to reach your service would say that, look, I have a timeout of 1 second or 2 seconds or 3 seconds. It can be exponential or infinite. Now, in this period, it could have been a problem at their end as well. Or when I say there, it's even if you were doing this in-house, let's say you were actually deploying your own geo farms of these network monitors. Let's say you were. Even in that case, you would have to answer this question as well, that in a case where you could not reach a service, think about this, many a times when we call a person on the mobile phones, and this is very prevalent in Indian mobile network these days, there's just silence. There's no sound. Like there's not even a tring sound. Like it's nothing. It's not ringing. Is it your connection that is bad or is it the other side that is bad? You can never tell. Your only option is to disconnect and dial again, and somehow it magically works after that. This is that state of unknown. You don't know whether I am down or whether the other side is down. So you need to mark that state as I cannot conclusively tell whether the system was up or was it a failure. Underlying reasons could be X and many.
Got it. Okay. Saurabh is asking, do downtime monitors publish these numbers? Any good ones that you'd recommend?
Uh, when you say these numbers, the algorithms or actually the numbers?
I think he means the numbers as in
So the numbers are usually there, like they actually put out their own numbers as well. And in fact, which is why, if you ever wondered why some of these downtime monitors actually force you to do a geographical hit, the reason is that because they internally go through the same battle of a multi-geo, where is that? Yeah, here. Should a failure at one geo be called as a downtime or not? And what they try to do is they see if other centers of, I mean, there's a threshold as well. This answer is also not as straightforward.
Okay.
So usually they would try to make it from multiple networks, and there's a threshold there that look, if X percentage of my failures were hit, then I'm going to count it as some problem. And their own the agents where they're deployed, they have to guarantee that they're not on the same internet lines as well. Only then they can conclusively tell that, look, this is actually really two separate agents of mine are seeing this as down and not just as one agent.
Got it. Okay. Okay. So he says by numbers he meant the SLA.
Oh yeah, yeah. Some of them actually do. So Pingdom does it, but again, that's just SolarWinds is actually a very clinical company about all of this. And if you go about reading a bunch of the documents that they've actually published and released, they speak in detail about, like, if I've only spoken 30 minutes about the challenge of uptime, they have a lot of documentation around this. This is just the tip of the iceberg.
Wow. Okay. Okay. Let's go through some of the other questions. So Vibha is asking, do you suggest more products to be coded from scratch, especially in case of innovations? Saying in reference to the statement that plugins only spawn metrics. Okay.
Uh, Let me try to understand this question.
Yeah, I am a little confused as well.
I think uh, the key thing here is that what we are saying is uh, it's probably should we go about innovating these things, or should we build these monitors from scratch? Obviously, I wouldn't
Hmm.
advise at all to actually build this. Like, uh, I mean, even if you were, you would just be lucky that any one of these problems you never hit. But as I said, like uh, uh, the more often than not, I actually say this. You get hit by a curse of knowledge. The more ways you know a system can fail, that many number of ways the system actually starts failing. So
Yeah, yeah. And that is where last nine also comes in, right? So Weber, I'd suggest you reach out to Piyush
yeah,
and last nine.
I think while I'm on a Gojek meetup, I can't advertise last time here.
Okay. Another question by Saurabh. He says, given that best practices say that SLOs should be clinical, precise numbers, and now knowing that there isn't a clear, accurate way to measure them, how does that impact error budget calculation when stability release decisions hinge on them?
Oh, very, very. It's a brilliant question, actually.
Yeah.
Because I get faced by this question a lot. I used to be, because working with a fintech company, there is a massive responsibility of you to not fail, and there are strict SLAs that you have to adhere to. So over there, the error budgeting, it resulted usually in cost expenditure. What I mean by that is that if I know there's by any chance that it's a I am going to be slapped with a SLA of 99.9%, let's just say hypothetically, I will actually design my system to be 100%, because I know that, and again, I will not reach that 100% obviously magically. So assume that my baseline calculations across a period of time, like the first question I'll ask myself is, what has the baseline been so far? Think about it, right? If my baseline itself was 80% so far, somebody coming in and telling me that, look, 99.9, like, it's a good joke of the year, man, like, it's really, I mean, it's not a magic wand that I'll reach there. What
Hmm.
I instantly mean is, more than the error budget, there's a business budget now, that look, from 80 to 99, I need X number of dollars to actually reach there. And suddenly I'll have to shift my gears from velocity to stability of my entire operations. because this is a massive jump. What we are saying is a 25% improvement, almost, like near 25%, from 80% to 99.9% is a near 25% improvement. And going through that hall of improvement means literally for a month, I'm saying no deployments, shut everything, no new velocity happening. We got to stabilize this existing ship and then probably hope to get there. Uh, and yeah, that would be my answer to how, I mean, then error budget becomes a byproduct of all of this.
Okay. Okay. Another question by Saurabh. So I'm going.
How many Saurabhs are there?
There's only one Saurabh. He has asked 3 questions. So in case others are wondering why am I taking only his questions, I'm just going by the order. We
Can we
have some.
just do a rate limiting?
So we have some time. I think we can take these questions.
Yeah, yeah.
So he asks, how do you measure SLOs? Do you have one big massive dashboard showing SLIs for your services? Any tools you'd recommend to get better at calculating nested SLOs?
Right. I mean, look, to be fairly honest, and really, I don't want to advertise last night, but if there was an easy answer to all of this, I won't actually be building last night. So, I mean, the thing is that there is a little challenge out there to put a perspective of these numbers, because, as I said, it's not one single layer; it's multiple layers, and these dashboards usually are. If what is the purpose of a dashboard? Is it to tell me that something is going wrong? Well, okay, and what do I do next? Like, quite evidently, by looking at a dashboard and then reacting to it, the battle is already lost. That error budget, the objective, everything has already been beaten. It's almost impossible. As I would like to actually bring that fact here again, these SLOs and these dashboards actually remain just a confirmation of how proactive I have been. What that means is the larger good is to actually look at the end of the week rather than every single moment. Every end of the week, we need to actually look back, see, okay, all went green or what did not go green. And what did not go green is pulling my baseline down. And then I need to look back at it and what can I improve and how can I improve this. So uh, I think to answer it subtly, I would say that there you could create those dashboards using whatever topology or technology. Dashboards won't help much beyond a point of time. What will help is real automation and real clinical actual calculation of where are we losing this.
Okay. A question by Prashant. It says, how do you avoid devolving uptime calculation to turn into tracing for a distributed system? Because at the end of the day, you want to follow the full life cycle of the request.
Right. This is where the different SLOs come in the picture. If I
Okay.
go back to the almost to the start of it, right? These are the different 4 tenets that we actually know exist. What you're saying is your action is availability, speed, correctness, freshness, a bunch of these. And across each layer, like let's say an uptime of a upstream service will not affect my uptime. It will actually affect my error ratio, my correctness. So while I'm up, I'm not responding a correct data. That's a separate SLO that needs to be set. That out of 100 requests that you get, you have to serve at least 90% of them. And you would actually be surprised that the other SLOs are not as stricter as uptime is. And uptime says goes about 99.99, but correctness never goes about that value. Because when you talk about request tracing, etc., what I'm hearing is the undercurrent of the question is that there is a lot of, I'm clearly imagining microservices environment. I'm imagining multiple dependencies, both upstream, downstream, and which also are going to have a hop, etc. I don't think any of them is actually going to affect your uptime ever. It's always going to affect your correctness SLO and not the uptime SLO. And then they need to solo and they need to, so every layer will actually keep adhering to their own uptime. That look, I'll be up for 99.9% of the time, Will I be correct 99.99% of the time? That's a different challenge altogether.
Correct. Correct. Okay. Okay. There are a couple of questions around what do you measure, as in what are all things that you measure in a deep health check? Is it the DB? Do you, or some action like
It's a
login,
actually
checkout?
brilliant question. So, I
Yeah.
mean, you'll be surprised to know that a lot of people actually don't do any of this. And the
Okay.
question of deep health check only comes in every once in a while where, and most of these, they happen after a failure. Once we've failed is where they're like, oh, damn, we missed that thing. So, and oh, I got to add a new DB or a Redis cache health check as well. So, uh, advisably, the trade-off that we'll have to take is between the frequency. Uh,
Mm-hmm.
what I've seen is that, and what I've followed personally is, I keep two such health checks. One is a very lower frequency uh, check which tries to go through the whole process of creating a transaction, but then this particular health check, because it's very deep, also leaves another hole. I don't want to digress into that side of the conversation, but it needs to be called out. Security aspect of it, like that can't really be a very public URL. Like where you just keep hitting because some bot is going to sniff it at one day. So it's only whitelisted from certain sources, but that's a deeper health check that I would enable, which runs every 5 minutes or something, which tries to actually create the whole transaction. Another something which actually tries to get something from any cache layer underneath as well. And while the other ones would probably just try to get the same stale data if for whatever reason they had to do it.
Okay. I think you opened a Pandora's box of queries with the presentation, Piyush. There's another question. How to consider health of external third party as part of our health? Should that be part of the uptime metric?
It can be. It will show up. I mean, you can. Now, this is where. So, this is how these conversations evolve, right? I mean, the first step is obviously having these questions. Now, the
Yeah.
next time you're building a payment service, right? Now, you have a question in your head that, look, I'm actually dependent on a payment service. What is their SLA like? Are they going to give me an SLA? And if I go back to this New Relic thing here, right? Over here, or else what? This or else is the most important aspect which actually improves our service level objectives. Example, if my upstream payment gateway is not responding for consecutive 3 requests, I need to switch to an alternate provider.
Mhm.
Or there could be another. I mean, I'm just saying that this is where the questions start. Now, how important is the customer experience to me? Because at the end of the day, what is the objective of this, right? The customer should be happy. What I'm saying is that, okay, I try once and I say that, look, if 2% of my requests fail, I'm going to switch to another alternate payment provider. This could be one of the actions and the outcome of a SLO, right? Fine, we do that, but that also fails. What next? Now you would say that if 2% of the collective payment gateways have failed, we probably need to switch to a post payment model. It could be even as drastic step as that. Fulfill all orders, we will actually come back and look at it again. And these are the decisions that one may have to take when there are upstream SLAs and SLOs being beaten, because as much as the first fact is you need to monitor them and not manually. Systems have to monitor this for you. Like they need to automatically be doing all of this underneath so that they can take a corrective action around it so that the rest of the system can still stay alive and afloat.
Got it. Okay. Uh, Another question. If I'm creating a product from scratch, what should I be doing to ensure that my product is measurable in terms of SLOs, SLAs? Very
Uh,
basic
this is a
question.
very, I mean, I probably give an opinionated answer here on
Okay.
something that I have done.
Okay.
I prefer outside in first than inside out. The reason for that is because every inside out, when I say inside out, usually what we do is, add New Relic, add this, add that, and suddenly we got like a blotch of 15 lines of code protecting one single line of code. And I've got tracing as well on top of it. I got this, I got that, and every time to change it, I need to push a new piece of code. Now, uh, inside out requires a certain kind of, this goes to humans as well, right? Whenever you report to a doctor that I'm not feeling well, they don't open you up straight thing, right? Like the first thing is outside in, thermometer, like regular checks, heart rate monitor, like anything which is pervasive in nature, like is deeper, is one costly, and two, it cannot be agile as well.
Mm-hmm.
And a deeper understanding of what should be sitting inside my piece of code as inside out is requires a certain degree of maturity of the product. I'm not saying maturity of a person, it requires a maturity of the business and a product of failures, how I've seen it. That, okay, I've seen incorrect data as well. So probably I also need to measure what is the byte length of the packet that is being coming in. Like all of this, it could be as deeper idiosyncrasy as that as well, which is so deep rooted into my business logic. Until I've reached that sort of maturity of my failures, the best way to go is outside in. And you start with that. It allows you to collect that behavioral data and help you to move towards whatever your objective is.
Got it. Okay. Ahmed is asking, can you share some examples of defining an SLO backed by business economical value? That is, how do you sell it to product businesses to be prioritized over features?
Right.
So some
So,
anecdote if you have. Or
yeah. So I do remember a point of time where uh, one of the SLOs that we had to capture was freshness of data.
Mhm,
And the reason for that was we were serving a lot of data through cache, and other data was actually served on a very, very cold storage. Now, our two choices were either we keep serving stale data, or we actually process the data as fast as we could. Now, some of the financial institutions were actually reporting not having to see updated data as often as they would like to see it. Now, this was a clear example of where the SLO had to come up that, look, because this results in customer tickets on Jira, on Zendesk, it required a very stricter measurement of how early would we see the data being changed. Now, this is one of the only times that, one of the very recent correctness based service level objective that I could actually remember, or freshness based rather. And because the lack of it was a constant threat. Like I can't measure what would have happened if I would have refused to do it. Obviously, that I can't tell. Like, okay, I won't do this. I don't know what the business loss would be. The sales team, the business guys came in saying that, look, we need to have data updating because the customers are complaining that it's not updating. Now, this led to a automatic SLO being defined that, look, every X milliseconds or every X seconds, the data has to refresh itself. So that required building a toolchain in itself, which would actually measure it and would mimic the client in a way. And the implementations were fairly complex, but this is one of the clear recent times where I saw SLO actually being set as a direct function of number of Zendesk tickets were being created around it. And one recent thing I remember was somebody was running a mobile application, and they had their Play Store ratings go down because people every time. So it was a common trend. It happened only twice in 2 years that as a content platform, if their content was not being playable, people would actually start down rating their Android application. Now, this because a down-rated application, down rating on an app store affects you directly because that is something that most of these mobile applications live by. Like having to maintain a 4.5 or a 5 on an app store is a great thing. Now, a sudden drop to 4 would actually result in embarrassment and also result in lesser customer acquisition. Now, as it goes, capturing this 4 rating is very late because the data from Play Store would actually come in gradually as people would start downgrading it. Now, But what you could have captured is it that are all my videos, the way they are getting served, are they being served in as much time as they should or not? So if they are being served in X milliseconds, there's a direct correlation that people actually don't complain about it. And this is what the product team had to tell that, look, I mean, how did they tell? Obviously, they could read the down ratings as well and see that, oh, videos are not playing. So, I mean, it's clear, simple, right? That's what they're complaining about. That's another second example that I would like to give. Would they suffice?
Yes, I think that was clear. That is helpful, Piyush. Okay, since you mentioned tickets, there's a question. Would you recommend hooking up your ticket creating tools like Jira to be used to track SLOs?
In your head, yes. In
Yeah,
the decision making, yes. Like,
yeah.
here's one of the things that I ask, and I think they should actually clarify it. There was a bug of 500 somewhere. There was an error alert that was raised from a server,
Mm-hmm.
but no user was around at that time to experience it. Should I go and fix this problem? Right. So the answer is no. Like, why should I fix it if nobody saw felt the impact of it? You know, like obviously impact can be debated. Like, but oh, what somebody would have felt an impact 3 hours from later, etc. But let's say in the for the sake of a philosophical study, we say that for a good enough period, nobody felt the impact of it. Should I fix it? No, obviously not. And this should help you understand that tying it mentally with the customer ticketing system is actually the single and the foremost reason why these SLOs begin to exist. You know, like they don't exist as 99 because they're fun to do, but just because there is business that hinges on it.
Right. Okay, we'll just take one last question, Piyush. If I want to set an SLO on throughput, behavior during day and night is different. How should be I thinking about it?
Yeah, so this goes into deeper end of the anomaly detection. You would actually build some sort of Bayesian models there. And also, again, I would refrain from using this word because we're going to open a can again. Throughput is self-disputed. Maybe that's another term there. Is it transactions per second or is it concurrency?
Wow.
That itself is a massive challenge of throughput to measure with. And let's, for sake of simplicity, say that you're actually doing TPS and nothing else. In TPS, it would like because concurrency is slightly harder to deal with measuring it. So if it's TPS and the day and the night systems are different, your monitoring systems have to evolve with it, and which is why you would require pretty sophisticated tool chains to do it. uh, yeah, I mean, sign up for last night. So
Got it. Okay, with that, our time is also up, Piyush. Thank you so much for taking out the time. I'll share your Twitter handle in case someone wants to reach out to you. And thank you so much, everyone, for attending. Once we end the webinar, there'll be a feedback form which will open. Please do take out 2 minutes to fill that up, and that will help us in making the uh, upcoming sessions much better. With that, I think we are good to end this. Thanks so much, Piyush, again for taking out the time. This was super interesting.
thank you, Ayush. You were a lovely host. Thank you. Bye.
Thanks. Thank you. Second.